Hi, hello, and welcome to the last day and the last session of the Tech Days. So this is the kicker session. Those people who are here show the passion to be awake still at afternoon. That's great. That's the best session time I can have, really. So we want to talk about the LLM for the database project and especially for the practical guidance we have out there on Codeplex. We created as Rangers. So the objectives are for today's session. We want to show you how you can manage and develop database projects with Visual Studio. Most of the people, and I will do a quick survey afterwards, don't use Visual Studio for the database project. And that's really a pity because you have great opportunities to manage database projects with this tool and with this addition. So I want to bring this feature to you, show how to use it, how to use the practical guidance around that, and what resources you should get to get familiar with it. The next thing is that I want to show you, because that's an ALM session actually, so an application lifecycle management session, to show what does actually database projects have to do with the application lifecycle management. Map the stages of the lifecycle management, you might have already heard of that, and see what we can cover with the project type in Visual Studio. Next thing is, I don't want to make any, would say, database officers of you. You just need to know which processes are best to be formalized to build, develop, test, and deploy your databases. So there are a couple of processes that need to be adhered to make sure that you take the best of the project with you. And for sure, to get to know the guidance document we have out there in the Codeplex and to make yourself familiar with. So I'm Jens Süßmar from consulting in Germany, Microsoft Consulting in Germany. I mainly do .NET development as well as database development, do a little bit of SQL Server, so I'm MCM and a core ranger, working with the product group to bring the experiences from the field to the product and to guidance documents. So the first question for me would be, is there anyone in the room ever having glitches in database development, building, testing, and deployment, where he said, okay, if I would have a formalized process or a project type that would support all that kind of stuff I need, from development up to deployment, that would be great. Anyone have ever any glitches around that? I can see it. Okay. So the rest is fine, or never had any database projects right now? So the rest is fine. Okay. So we'll ask you later how he did that. So the problem is normally with this kind of sessions, we can do it the shallow way, so doing only the ALM stuff and doing something like we are just tipping a session, a project, a feature or something, or doing the really content depth. I did both sides, but the problem is most of the people didn't know actually the Visual Studio database projects right now. So they're sitting in the room and asking themselves, okay, that's a great new feature, but I never heard of that. The product is now 5 years old, but I see that all the time. So my question would be, who's doing database development on SQL Server? Oh yeah, that's great. Who's doing the development on Oracle? Oh yeah, quite a bit. Whoever used Visual Studio database projects and had problems with it? Oh, great. Almost no one. Okay, so we find a problem, and I think we can solve that. So we won't cover the Oracle part of of the Visual Studio. You have a database service provider which supports Oracle databases in Visual Studio, but the main one, which is shipped by Microsoft, only supports SQL Server. So we are covering that, but the main task around that also apply to Oracle, because I will present you a paradigm how to build all the ALM stuff into your database projects, no matter which database service provider you use. Where are we in the application management process? So we have to differentiate. I don't want to stress all the application lifecycle stuff, but I want to stress two parts. We have the application lifecycle management, which we'll see, which can be seen as the governance part. That's the black part. The actual development part is the software lifecycle development, and that's the green part here. We will be covering with the database project for sure the development part, but also the operational part. How did we do it? We separated the lifecycle of a database into 4 main areas. That's development, build, test, and deployment. According to ITIL or ALM, that's the service creation, so all the stuff around development, testing, and building, and the operational part, which is deployment. So we will cover in this session almost every part of the 4 main areas, and we'll show you how to do that and where to look up resources to get really started with that. One step back for the development tools. So we're asking ourselves, where have all the database projects been, the system, the database project system? There hasn't been anything since 2005, where the actual database project add-on came on for Visual Studio. Prior to that, we only had the separated tools for testing, building, and all these separate tools needed special kinds of expertise. So no one could ever handle all that stuff. And that was what made the actual database development really hard. With Visual Studio, we had one tool to bring that all together, so all the 4 main areas I talked about. And we could handle that with that. Because prior to that, whoever did, prior to the Visual Studio database project 2005, database development in SQL Server. Okay, so just a quick question, one of you. How did you do that? So source controlling stuff, deploying stuff, maintaining stuff. Yeah? You cannot. I will point to you. You raised the hand. So you did development prior to Visual Studio, right? You wrote scripts and put them in a. Yeah, and those scripts were loosely coupled somehow, right? Yeah, that's the main problem. So thanks for the answer. The main problem is we only had these loosely coupled scripts, leading to the problem that although we had the application, like the classic auction application here, which is built and produces an assembly in the output, which can be simply used and just copy and paste it to some directory and start it up, and that's it, so simply replaced by another version. We have the databases, and we have one problem with databases, data. We have to preserve data. So it would be an easy thing to just drop the database, create a new one, and that's it. In some cases, that might work because you don't need the state of the database, or you don't need to persist the data. But in most cases, you will have to preserve data. So you wrote a beginning script with the version 1. Then you started to make changes to the actual application, then to the database, rolled out the changes, but you needed to preserve the data. So you needed to create an update script schema motion script, which in that case added a constraint to the table. Then you added another constraint to the table, and so on and so forth. So with these handcrafted versions, you have the X thousand lines of code schema motion script, which was not really version agnostic, so it has to be run completely or with jump markers or something in it. And it was really hard to maintain. The problem with that is also once you created an index in, let's say, version 1, you dropped it in version 5. So you did all this stuff, creating an index and dropping an index without any sense after it, because at the end, what counts is actually the target model is that you don't have the index. So it's useless work you did during the schema update, and it could be avoided. So you either had one main script that was X lines of code long, or you had these simple motion scripts. So from version 1 to version 2, from version 2 to 3, 1 to 3, and so on. So you have 100 versions, and you need all the motion scripts from the version 1 to the version Z. So that's actually a problem, because maintenance is really hard. You really need a lot of effort to maintain that. Yeah, and that's the main problem with that. So instead of having to use, and that's a real-life example here, that's a folder from a project where the actual schema motion scripts were put in. So no one except the developer and maybe some of the administrators might know in what order these scripts are to execute to get to the target model. So it's hard to get the intellectual property, so the experience from database administrators, from developers, into the project, into the application lifecycle, and to build a really quality solution afterwards from the database. So as hard as it is, the enemy of the database developer is the data. So we have to preserve data. That's our actual problem, because otherwise, I said, copy and replace will not work in the database world. We need to create incremental scripts, no matter which version the source is from. We need to get to the target model, however, with some scripts or whatever. The problem with that is you can't really change a table if you have constraints on it, referential constraints or indexes or whatever. You will have to drop all the dependent objects, make your modifications on the actual table you want to change or on the actual object, and then recreate all the stuff. So that sounds hard, because you will have to know all the dependencies, you will have to test that very deeply, and that was the main problem in the prior days before for the database project. So where are we now? That's the main part, because we are now in a new database project world, and I want to show how that works now. We are only thinking as the target model. We don't care about the actual intermediate steps to get from version 1 to version Z. We only have the existing model, which is the old database, maybe the real database, and we have the target model. And we don't care actually how to get from that side to this side. We only want to have the deployment engine create the changes. And that's in that case here. So we changed the table. As in the other example, we added another primary key and we added another unique key. That creates, for sure, for a new deployment, a create table statement. So create database, create table statement. But for an incremental deployment, this creates automatically the schema motion scripts for that. So we don't have to care about dependencies, because that is all done behind the scenes. And we can simply work to have our target and focus. So changing database, not doing any deployment. That's the important part. So if there are any questions in between, just to ask them. I might not see you, so either shout or take them at the end of the session. That's also okay. I prepared a session to have a little amount of time for open questions. Okay. So the advantages, just to summarize, we only care about the schema model as it should be. We don't care about deployment time. We, as database developers, only care about development time. Deployment time is automatically done. That should be taken into your memory for that. And we are working only on a conceptual model. And with a conceptual model, we are able to use all the magic stuff like branching, merging, labeling, which is available in TFS, which isn't possibly, which is not easy to do. Let's say it that way. If you only have these loosely coupled scripts. Okay, so the various tools we have. That's another problem. You might have tools for comparing data. You might have tools for schema validating data, for, let's say, data generation, unit testing, all that kind of stuff. But we don't have actually one in-place tool to maintain or to support all these application management cycles. So these tools are only operable from the people who are in touch with that every day. So the administrator might know SQL Management Studio, but he doesn't know Visual Studio. The tester might know some Test Studio or might know to execute tests in a specific order, but he's not aware of creating actually tests because that's too hard. You have to create unit tests with code and all that kind of stuff. So we needed to do to have a tool that does all that behind the scenes and will have a good designer for that. So that is Visual Studio Database Project. Just at a glance. Just if you haven't been familiar with that, that's just a small peek into the product. You will see something of that of the product later on in the demos. So we as Rangers, there's a group called Visual Studio Rangers, which directly works with the products groups to bring the experience from the field and all the experience we had with the product back to the product group, maintain, create documents to show how to use certain features and bring them to Coplex. You might already know the merging and branching, the lab management document, all that kind of stuff. And we have the new document, which is called the Database Projects Guidance Document. So what's the difference in a nutshell between the MSDN documentation? We don't want to be a rival to the MSDN documentation, for sure. We only want to be an addition because we are scenario-based. We have scenarios which are in the real world very common because people from the field produce these scenarios. And we are going step by step through the scenarios to bring you all the experience from the database project. We, as mentioned, we showed experience on real-world engagement. So we took back all the experiences from our projects and stuffed that and extracted that and stuffed that into the document. So what does this guidance document consist of? It's a guidance document, first of all, just the overview. What does database projects do? How can you do that? What are the certain features you might use, you might cannot use in your projects? And then the hands-on labs document. There are plenty of hands-on labs for that to implement, let's say, partial projects or more workaround for replications, all that kind of stuff. With sample files, you can simply create in your machine, restore databases, and let you run through all that process. If you want to skip something because you say, okay, I already did that step and this step, I don't want to do that because I lose time with that, you can simply jump into the extended step and simply finish the lab to see how it's done, or simply only show the results of that. We do focus on five areas, actually. That is, from an LLM perspective, the development. So we have this solution creation, the project management, all the stuff with branching and merging. From build and development, so integration into TFS, building projects locally on your machine if you don't have TFS, and deploying database projects. So deploying into the real world, not just throwing artifacts over the fence to the actual DBA. So helping the DBA to deploy database projects and to maintain a certain quality. Okay, so let's start with the first one, the development. With the lose a couple scripts, it's never easy to see if you have honored certain dependencies. So if you create or refactor a certain column and you use it in a view, you use it in a procedure, you won't see the actual changes or you won't see the actual errors you produce because you referenced the column in another script and you didn't change the actual column name in it. And that's a problem. You only see that during development, during deployment time. And that's really late because you want to see that during development time because you're a developer and you want to fix the problem you created. So that's the problem why 1 and 1 is sometimes 0. It does seem that everything is right, but as from the picture you see the certain parts didn't fit together. So the fit together part is actually what the database projects do. You create a project, and during development time and during creation time, you already have the validation of your database code within. So you don't need to catch up all the errors during deployment time. You can simply validate that on the fly with your database project. So developers can also be provided with the templates from your company to say they need to adhere a certain template for creating views, to maintain comments, etc. So that is already stuff within, and you can extend that. In addition to that, that's the change from the version 2005 to 2008. You don't need any database in the background. You are working totally offline. You're creating your database simply from scratch in memory. You don't need to have any SQL Server or something installed. You just need to have Visual Studio installed. So what's the guidance about in that area? The guidance is about managing projects. So if you haven't started already with Visual Studio database projects, it shows you how to create projects, but not only that, because that is already mentioned in the MSDN, how to manage projects. If you need, for example, composite projects, partial projects, server projects, that's all terms you will read in the guidance document, I might understand them later, how to apply merging and branching to your database. What need to be merged, what need to be branched, what need to be versioned in common. So that is already mentioned in there. And it makes you aware of all the limitations you have, like the Visual Studio database project doesn't support, for example, change data capture if you have that. You will have to get around if you have set up replication on your databases. You will need to have a certain script in there to maintain replication, because that is not included in the project. And that is already mentioned in the database document, you can see. So for all of you who haven't seen the Visual Studio database projects as of now, I will simply show you how to get started with that. Just as a side note, the Visual Studio database project is already included in Visual Studio 2010. So it's no separate download, it's already included. You can use that, you can start right up tomorrow with that, no problem if you have Visual Studio. And for a quick sample, I show you how that looks like. So we will create a new project. There it is. So we have database and SQL Server database project. So I now create TechDays 2010 sample. Okay, and right now we already have set up all the infrastructure for the project, all the template are in place, but we want to reverse engineer our database. It's very easy because there's an option for that to import database objects and settings. You simply choose your database. In that case, we have set up the AdventureWorks database as we have in our guidance documents you can work with. You start the thing and it will import the database artifacts from it, so tables, procedures, and all that other kind of stuff, and we'll put it in a project. Right now, after importing the project, you are ready to go. You can deploy databases, you can start developing databases. You don't have to be connected to SQL Server anymore, because right now you can shut down SQL Server. You don't need anything more. You can just develop here in Visual Studio from scratch. Or not from scratch because you imported all the stuff. Okay, so you see we have all the schemas in here. Okay, we don't have any store procedures in here, so and we need to wait a bit because the schema model is analyzed behind the scenes, and that might take some time. Okay, so it's done. Okay, so we have the store procedures here, and almost like a management studio, you can simply work here from that and can simply compile all the things, build the things. And the good thing about that is, as I mentioned, if you do any changes in here and you have problems with that, so you don't have any errors right now in here, unfortunately, because you imported a new database and you make something like a typo in there, in that case, you get a warning because procedures can be changed because of deferred name resolution. That is only checked upon deployment time. But you already get a warning in here saying, okay, you are mentioning a column name that doesn't exist. Is that right? And that's the actual advantage, real advantage of Visual Studio, right? See that from development time and can decide what to do. In that case, fix the typo, save the change, and that's it, your errors are gone. Okay, another thing is, if you want to deploy changes with that, so you say, for example, you have a table and you want to add another, let's say you have this table here, error log table, and you want to add another column in that, some column A. So that is done. So it's now already present in your offline model. It's already modeled behind the scenes, but you want to deploy that to the actual database. So you can simply click on here, and first you need to set up the project for deployment. Tell the project where to deploy and to what database. So I'm right now deploying on the AdventureWorks database, and create deploy. So the build is started, the model is validated, and the schema motion script is created for that. So what does that mean? The schema motion script It's all the script you need to get the original database up to the new version you created here. By default, only deployment scripts are created, so only the SQL files. But you can also deploy from Visual Studio directly to the database server. The main problem is that in most cases, you don't have actually access from Visual Studio to the database server, like testing, production, or some servers or environments in between there. So we need to have another shipping vehicle for that. I will show you later. But from that point on, if you have a development server and you want to deploy from Visual Studio, that's the actual way to do that. And I can open scripts to see what is done behind the scenes. So a lot of plumbing. But here we see the schema motion script, so it's altering a table. There's nothing to be done. You don't have to maintain any schema motion scripts. It's all done from the deployment engine. That's a real advantage. Okay, that's for the people who didn't see that yet, how to get easily started with database projects and change your projects or your development right away. So the next part is build. Build is a different kind of stuff. Build is done already behind the scenes. We saw that. But the local build is not even similar to the TFS build. The TFS build is there to build a common confidence of your code, not the actually it works on my machine code. So a build might look like okay on your machine, but it isn't almost okay in the general environment. You will have to integrate all the builds, all different databases together to make the build really high quality and maintain a good confidence about that. So we were talking about the guidance in the guidance document about the practice, how to integrate that in TFS. So first of all, if you don't have TFS, we are talking about MS Build. So to set up an automated process without using TFS, having only msbuild.exe. We are talking about building that in the continuous integration in TFS. So after XYZ check-ins or directly after check-ins that a build is done. We are talking about automating tests directly upon check-ins or directly upon builds. That means to directly verify your quality of your database schema changes. And we are talking about deploying databases right from the build. So you might have seen that, or you have already seen that there are errors which are shown up directly upon development time. So there's no excuse for developers anymore to say, okay, I didn't see that stuff because I didn't have the opportunity to deploy the database because the schema validation is directly done behind the scenes during development time. But there are, for the excuse of the developers, there are certain errors which are only discovered during deployment time. And that's it, for example, like declaring or missing a declaration of a variable in a SQL script. That is only known at development time. That's the opposite of the, or I would say the disadvantage of database projects. We are also showing, and that's a really important part and a really exciting part, we are showing how you can deploy your databases with the Windows installer kit. So you can create, you have an application, you have a database, and you want to deploy that as an ISV, for example, to a customer. How can you do that? Normally, the customer buys, I would say, consulting hours for you to implement that. But maybe you want to create something like a CD with a setup exe, and simply want to give that to the customer to install things. That can be done using the Windows Installer XML kit package. And you create your databases, your application, your web application, your console application within, and deploy that right away together. We will show that in the guidance document and give you a sample where you can work around, change things, adapt to your needs, and simply work with that. So I want to show you the sample of the Wix installer kit we created, just to give you a quick view how that looks like. So from the structure, you might see that we have the products. The directory structure is right from the hands-on lab sample files we provide on Coplex. So we are navigating to the final output here, and we have the sample MSI here created. So we didn't change any licensing terms, or we didn't change any content from the setup. But you will see that this is actually a database setup file or a database setup application, which turns out to have something like a navigation node in here, which says databases, and under the databases there are several databases to install. With that, you can also have at the top root level application node to say, okay, I can install applications from here. I want to install this application, that application. Define requirements between them. So you click application A, and you need then, let's say, for example, database A and database C for that. And then you can simply install databases right from the MSI installer. Whoever is not familiar with the Wix project, that's an open source project available also on Coplex. We're not doing any Wix tutorial within, but we have some great mentioned resources from that where you can get yourself familiar with that. But the best thing is actually to start with our sample here and to change things to your needs and simply try to adapt that. I can show you on a quick view what the installer project consists of. It's really simple because it's all XML based, so you can see how the products are, for example, specified in here. So you will need simply to have something like this here inserted. The nodes are also explained in the XML database guidance document. So it's really easy to pick that up for you and to create your own installer package. Okay, next thing is the test. The test is sort of a thing people or developers are most likely not in touch with, because it's almost work to do or it's almost time that you need to spend on another development tasks. But the problem is that developers need to do that because they for sure have to provide a confidence over their own code. They need to ensure that they have coded the right way and they have the expertise to actually code the stuff. The problem with testers is they can execute tests, but most of the testers I know cannot code any tests because they can only follow rules to execute tests, and that's it. So why testing is important is that you don't want to lose control over your database during the flight mode. So you want to make sure that you will have all the tires tied to your machine before you actually run on full throttle on your race. The idea behind that is and that's from actual Gartner document, that you will have the most discovered bugs in the development phase. And that's the phase where the fixing of bugs is actually very inexpensive. It's very cheap. So you might want to push all the discovery of the bugs up to development, fix that, and not to have something like bugs in production and fix that later on, because that's a problem. You do not only lose money because you might have outages, but you might also lose the credibility with your customers because they have a not running infrastructure, or they have problems in their database. So you might want to push that a little bit to the development phase to make sure that you don't have any expensive fixes in there or any glitches in there. So the real advantage from here, from the database project, is that the creation of test was put into a designer. So you don't have to code anything, because coding is all done behind the scenes magically. You can simply create a test by a designer, check them into a unit test, and let them run automatically, either with their build or also locally on your machine. So in almost every project I established a process that every developer at least needs to write 2 unit tests for each procedure or each use case. And that is a positive unit test and a negative unit test. The chance with that is, or the advantage with that is, when you make changes, you can simply run back checks on your procedures to see if the existing functionality is still there and still works. So right up, if you take that process and really build up with every procedure, with every use case you have, these positive and negative test cases, you will have a bunch of test cases to ensure stability in your project. And that's a really important thing to memorize for the usage of Visual Studio. Not to only make yourself confident and say, okay, I'm a good developer, I'm doing development all the time for years now, and I'm sure that I write really good quality code. Make yourself familiar with the unit tests and write them. Even if they're easy, they are easy to maintain and they're easy to execute. The other thing is you want data in your testing databases. Everyone can actually execute tests on John Smith or something else with all the simple characters, but if you support maybe, let's say, NVARCA 500, have you ever tested your procedures with, if you have a surname which is of a length like 500, did you ever test your procedures with the actual length of 500? I bet not, because that's I think that's the length you once decided to stay in, but you assume that the surnames never extend up to 13 characters or whatever, or 30 characters or 50 characters. But the actual possible surnames or length of surnames is 500 or whatever 100. So you want to change with real data. But no one actually wants to create that data, because you don't want to create thousands of names with 500 characters. You don't want to create that on the fly and automatically behind the scenes. And that is what a data generator is for. You can create within Visual Studio meaningful or random or sample data from your already existing databases, and let that run or let that fill in your database to create or to run your tests. The next part is, and that's a really important thing, you can run your databases, you can run your tests within your builds. And that's the next thing to memorize. Automate everything if possible. So if you do anything, if you put any effort in tests, in data generation, in whatever, make it automatable. That's the really key point for you to memorize. If you don't take anything from that session, just take it, the one, make everything as possible automatable. Okay. So the options we have for creating meaningful data are the simple data generators. I don't want to go into that one, but you also can create not only random data, you can pull off data from your databases, from your existing databases, scramble that a bit, might seed a bit. Let's say if you have a sensitive database and you don't want to directly use all the data in that, you can scramble the data and reuse that in your tests. So you can test, as written here, the full complexity of your data types. So not only the John Smith types, you can only take 500 characters of something and put it into your test and let the test run. If you have the positive and negative tests, it's really to run them automatically and to ensure your quality. That's the main point. If that isn't enough for you, these generators, you can also create your own generators. I had that several times where the customer says, oh, I have an SAP interface, I have a web service or whatever, I want to query data for, and I want to use that in my project. So we created a custom data generator, which has a really simple interface. It's something like, okay, start data generation and give next value, give next value, give next value, and that's it, actually. So you can simply call a web service if that is appropriate from the time you need to access the web service, but you can also use, I would say, custom assemblies to simply generate data based on business rules the customer might already have. We had that in a bank where a certain risk analysis was run, and from random data, a risk value was generated from these custom assemblies. So we use that in a simple custom generator to access all the business logic from within. So what's in addition in a database document? We do start with a simple unit testing. So a simple unit test, I will show you later, and put them in a project. Then we will show you how to create something like a multi-step build artifact. So you build your database, you deploy your database, you load your database with data, you test your data, you publish the test results up to TFS, and you tear down the database afterwards. And you don't have anything to do with that because that's all done automatically behind the scenes. We have a template for that. You can simply use and plug in your databases and your tests, like I would say test lists. You can simply plug in your test list if you have any of them, and then simply plug into your build, or you can also call that from MS Build if you don't have TFS in place. Okay. So a quick demo for that. So a quick demo for those who haven't seen unit testing right now. Is just one point. The thing I'm showing these simple samples here is that I always have people in the room. I think people used to use all that stuff, all the unit testing stuff, etc. But most of the people who are not familiar with these projects, or even if they are familiar with these projects, might not use every feature of that because they are not used to that, because they didn't see that yet. So I might to get simple samples to get them in touch with, and that's why I use here now a simple unit test just to make yourself familiar with that. So I navigate to some procedure. Let's get the bill of materials, change myself to the schema view, which is actually the schema model view of your database. The solution view is the view how the files are persisted on your disk, and the schema view is how your your project is structured. You click on the bill of materials and simply create a unit test. So create unit tests, and that's actually it. That is the way for testers to create unit tests. It's really easy because you don't have to code anything. You just have to create a test project if you don't have one. So I name that TechDays 2011 testing. Create a new class for that. Okay, so it's working, and that's actually it. You see here on the left side in the content view, you see C# code because I decided to create a C# project behind the scenes. And now you can choose certain properties. You don't have to. Actually, you can use that later. You can say against which database you want to test all that. You can say if you want to preload your existing database with random data according to a data generation plan. That is where the data generators are used for. And you can deploy your project prior to actually executing tests to make sure that you really have the latest and greatest database to test against. But I know I didn't change anything on the server because I simply reverse engineered the database. So I'm choosing the actual AdventureWorks database, and that's it. So the test is already created with all these with all the samples within, and I know from my conferences that for the check date 2026 there should be sample data within here. So I'm searching for, and it could be one approach of view. You preload your existing database with something, and then try to retrieve something. Like in that case here, you have a get procedure. So from the name, it turns out that it will return something. You try to return the value you are expecting, and then you use your test conditions in here, which are already delivered with the product. There are 8 test conditions within you can use, and you create your own. I will show you that later. But you can use, for example, the row count and test against the number of row counts that might return from the procedure. From my memory, it should be 6. So I expect the procedure to return 6 lines of products here. So that's actually it. You can save that, you can persist that, you can check that in, and you can let it run every time you do an automated build, and you have your test list assigned to your automated build actually. But you can also run that locally on the machine, and I will do that with run test in current context. So I still have this test method in here. So it's failed. Okay, let's see why that is failed. Okay, I simply did that the wrong way because that's an English format. Test run. So it passed. So it seems there were 6 rows returned from that. So if you change anything in your coding and the coding insists to return instead of 6, 7, or 0 rows, I will change that here in the condition as an example. You will directly see in the output that there's a problem, and that the actually asserted condition in the meaning of 6 row did not match the 7 expected results. So you can test simply with that your existing code, and it's really easy even for the testers to create their own test cases. They only have to know how to write simple SQL and how to fill in these values here. So it's really easy to use. As a suggestion, again to memorize, we suggest that you create within these test scripts here. So like before, the declare something as, you create a transaction, fill your data in your actual database, then do your testing, and afterwards do a rollback of that. So you can clean yourself from that. You can fill in data, you can clean data afterwards, and you have the same state after the test as before. That's really easy. That might take a little extra cycle to do the transaction and to roll back all the stuff, but it might be appropriate for only small tests where you don't want to tear down all the databases after every test and simply use the same database for each test. As an example, we have a project right now which is a public telecommunication company, which has around 1,500 procedures, and they at least do have in one database, so we have 1,500 procedures in one database, and they at least have 2 tests per procedure, so we have 3,000 tests, and they run almost in, I would say, half an hour or something, and it's really easy to maintain with that quality. A test to be created just needs 1 minute or 2 minutes. You simply fill in values, have your development studio or your management studio beside to see how many rows actually have to be returned, then fill in your data, save your unit test, and that's it. You have to never get in touch with the unit test again, just to consume the results from the unit test. Okay, so simple to create. That list here is a really short list, but that are the most common things you need. If you do need another unit test, so you need, let's say, you need to extend that, you can use the extension point here, the test condition, where you can simply create your own unit test, so your own assert procedure. And the interesting part in that is the deployment simply is just by copying the assemblies created from that to a file on developer machine or to the testing machine, and to create an XML file for that, so little describing which assembly to load from the test condition, and then it will automatically appear in the drop-down box we see in the testing case, and it can be simply used. So there's no installation or something like that. It's simply dropping the assembly in a folder, and that's it. And everyone can use this test. Okay, so the next thing, and that's the most important part for me, and that's my really favorite, is deployment. Deployment is you expect something to be deployed, but at the end, you might have a problem with the actual real-life database. So I would compare the database with the balcony here and the existing operating with the rail tracks. So you have deployed something, you're sure that everything works fine, but it blocks deployment. Why does it block deployment or the operations? The transition from deployment, so from the actual development to the deployment, shouldn't be something like throwing an assembly or an artifact over the fence. That has been there for years, just having a script out there, this finally whole script with all the version transitions in between we mentioned at the beginning. And in that case, it's only a schema file, a DB schema file. But we don't want to just throw the DB schema file over the fence to the administrator or the database administrator, the person in charge for deploying. we do want to help these people to get our changes to the database. So finding bugs early is it's really important for us, even for our developers. Another thing which is important, we don't want to just check our upgrade procedures or our upgrade from version X to version Z by simply on an empty database. We want to check that on real data. We want to check if certain constraints will hinder us that the schema update is really deployed on the server. We want to take how long does the actually deployment take place? How can we streamline that? How can we shorten that? How much log space do we need? Because those are the questions we were asked as developers if maintenance windows planned. So if you say, okay, I'm ready with my code, you can deploy that code. The project lead might ask you, okay, how long does the upgrade take? And you say, okay, I don't know, let's check that. And you check that on your development machine and say, okay, it's running in 10 seconds and that's about it. And so the maintenance window is planned. So the maintenance window is planned with 10 seconds, and the project lead might say, okay, we extend it to half an hour because there's some plumbing to be done beforehand and afterwards. But at the end, you don't need actually only 10 seconds, because if you have a really big database and you're doing schema changes that might cause data motion, that is meant that you take the data from one table, shuffle it to another table, tear down all the constraints and the indexes, recreate all the constraints. You can imagine how long that takes having a terabyte database. You won't be able to do that in 10 seconds, and you won't be able to do that in 1 hour or 2 hours. You might have a really realistic value for the duration in that case. And the administrator might ask you, the existing infrastructure, will that be sufficient for an actual upgrade? And we say, okay, my log space is sufficient for that. And you might see that if you're running the database upgrade in a transaction, you might exceed the log space that is available in the data center. We had that. We had that in projects at the beginning. So that is from my own experience. We upgraded the database and used a transactional schema motion for that, so that everything can be reversed by rolling back all the changes. And we are running out of log space. We attached data. We attached drives, created new log space just to keep the database upgrade rolling. And that was one experience that we had. We had the time needed, but we didn't expect the log to increase that much. So always test your deployment on real databases. If the database is sensitive, if the data is sensitive, test it in an environment which is secure, or scramble the data. But make yourself familiar with testing on really big databases. It's for you to build confidence about the deployment process and about your delivered quality. That's really important. So the next thing is that we as developers assume that the existing database we once created in production is the same all the time up to the time we deploy another version. But that is almost not the case. It's most likely that's not the case. I've never seen that because I always have model drifts in between that. A model drift, as from the term, is something like the schema changes from one version to the other. So we have a drift in the actual schema models. So you want to find out what these schema models are, because if the administrator created something like a foreign key constraint, created something like an additional column, an index, or whatever, it might affect your deployment time, it might affect your deployment quality, and even the feasibility if you can deploy your changes to a database. So the best thing is to check if the database you once deployed, and that's why you want to version that stuff, is the same as and is deployed in the real database world. So that is the next guidance we have in our document. We want to decrease the doubts of the administrator who says, okay, database upgrade will drop tables and indexes I created. So it will make the database slow again. So the problem with that is the operational part creates indexes and does all that stuff to keep up the performance of the database. But the schema changes don't flow actually back into the source control system to the developer. So we don't have that in our model. We carry around when doing the deployment time. So we want to check that. He's in doubt that the magical deployment command line, VSDB command, really does all the magic behind the scenes. So he wants to see if all that stuff is done behind the scenes and if that command line really honors all that dependencies. And he wants to, I can understand that, he wants to check the SQL file prior to deploying that to his database because he's responsible for. The developer doubts are, okay, like I said before, the developer, the database administrator might have added indexes and constraints and all that kind of stuff, and that might fail, might cause my development to fail or my deployment to fail. I want to check if the version I once created is the same as I expected during my testing. And I want to make sure that the duration of the upgrade is really predictable for me. So there are several ways to do that. From the guidance document, we outlined the different approaches. In summary, it's all about using VSDB command. For all of you not being familiar with that, we had the deployment engine in Visual Studio, but as I said, you normally don't have Visual Studio in a production environment. So you need to create or you need to calculate changes to drive the version 1 to version 3 of the database with another deployment tool, and that is VSDB command. So it's Visual Studio Database Command Line tool. You can use that and put in a model as a source model and a target model to compare against, and it will automatically create the changes or the motion scripts to bring it to the target model. So there are 3 versions actually in the document, which are sort of different, but all lead to the same solution or the same effect. You want to have something like an upgrade script, and you want to check that against your actual database. Okay, so I will show you that in a short demo. And that's, again, a thing I want you to remember, to have something like a toolbox with you with at least these folders here. So you have the expected database version, the found database version, upgrade database version, and the diff scripts. And you have a sort of batch commands you can start right from 1 to Z, and you simply go through that and compare these results with your expected results. So I don't want to execute that as a batch file. I want to show you that in the actual command line. So the command line tool is VSDB commands. And then you can put in an action. You can say if you want to deploy the changes to a database, this will actually change the database. Or if you want to create a schema, a script file for that. So that is actually not executed against it, but a schema deployment script file is created behind the scenes, and you can inspect that. So what does it mean? I will execute that for you to see. So we use Visual Studio command prompt. Expected database schema file. So here it is. So what's wrong with that? Okay. being in the wrong directory. So I'm running the vsdb command, and it will actually, let me see if I took the right one. I didn't take the right one. In that case, it will extract me the actual model from the database. So that is the suspicious, I call that suspicious DBA version. So the DBA does not want me to touch directly the database. He will give me the database schema prior to the actual deployment, that I can compare my expected version from the database with the already existing version, and might see, okay, there are differences. Do I need to take that into account and reverse engineer that to my database, or will I simply ignore them because they don't have any effect on the deployment? So the command does the following. It extracts the schema, so that is the new one here, 827, to a schema file, which I can take with me to my developer office and can compare with my actual data. I can try upgrades on that to verify the deployment, but there's no data in it. Just memorize, you need to test that also against data. But that's the one thing, I have the schema and test that against my actual implementation. So the next thing is that I can compare the database I brought to the actual deployment. With the schema file I have. So I don't want to deploy the database. I say, okay, I do want to deploy that, but I only wanted to create a script from here. So this will create a model drift against the live database. And the diff script looks like something in here. We already seen that before. So we have all the plumbing here, and it simply does nothing in that case because we have the same version. So there's nothing need to be done with that. So we are now comparing against a database, not the actually where reverse engineered from. That's one I created afterwards and created an additional table because the administrator decided that he wants to create a table too because he needs it. And I want to introduce you to another parameter we can use. That's an extra parameter. You can drop objects that are not in the source and drop that from your actual source code to make sure that only the objects you have in your source control are after the deployment existent in your actual database. So that's an interesting part, but that will bring anger to the actual database administrator because all the indexes, all the extra tables, etc., will be dropped from that. So you might want to use that wisely here. All the command line parameters are mentioned in the MSDN and also mentioned in our guidance document with hints to that, when to use what, and what you should consider talking about with the DBA first and how to plan your actual deployment. So that's a really great tool. That's a really powerful tool to make your deployments easier. Okay, I see we are short on running. We are running out of time, so I will quickly put on my summary in here. So according to the sessional objectives, I hope you can have a quick view of the database projects. Know in theory what there is in the actual guidance document. I couldn't repeat all this stuff in the guidance document in here because that's a 120-page guidance document and another 80-page hands-on labs document. So you might read that in a in a calm minute for yourself. But I really suggest you to read that, because those are the experience collected by us, the Rangers, by MVPs, and by several years of experience within projects. It's really interesting to read and to see if there needs to be changed anything in your existing environment, in your existing database code you already have, or if that confirms your way of doing things, because you already might have done that. So that is really my suggestion for you, to go out, read that stuff, take the time and read that stuff, and make yourself familiar with that, and confirm that you might already use that. So the database project, we already seen that, are part of the application lifecycle management you can use. It has all the 4 parts in it we need as a developer, and we need to support as a developer as well as the deployment. And there are some formalized processes you want to adhere to maintain stability, like creating unit tests, like doing test deployments, with creating unit tests, with creating random data, with creating all the spectrum of your data, so not only the John Smith sample, as I said. And I hope you take away with you that the guiding summary can help you to get around limitations. We didn't mention any of that. I simply mentioned the change data capture and the replication. But there are some more other features of SQL Server which might not be covered in the database project, but we have a suggestion for that, and from our experience, a way to implement that anyway in your procedures. So that is the information from the Tech Days. The sessions will be available on Channel 9 later, after being produced. If you want to see any information about Visual Studio or SQL Server, just visit me on my blog, or you can also drop me a mail on jens@microsoft.com. Another great resource is the blog of Barclay Hill, which is the program manager of the Visual Studio data tools. You also, as a side note, you also might look out for new information about the current CTP of Denali, which brings a new set of development tools for SQL Server. And you might want to check out the Visual Studio Ranger site. If you're interested in joining the Ranger community, simply use the contact button on there if you want to contribute and share your experiences with the community. Do that by either contacting me or using the contact information on the Ranger side. So, we are short on time. I started a bit late, so we might hit the right time. So if you have any questions, either public questions, or if you want to ask me privately, that's no problem. Just come here and we can talk about that. A big thank you for staying that long in the kicker session. I hope you have something from the session that you can take with you and implement in your daily work, or only read the document. Thank you for staying, and have a nice day and a good trip home.